Working? All right. Well, good morning.
Morning.
Pleasure to be here. I have a Purdue grad twice over, so this is actually enjoyable on a new exciting adventure where we're launching off of. I came from Rolls-Royce, so this joint venture we're working in, I'm from that side of the equation here. So I want to walk you through what is the joint venture, what are we doing, what are our products, what applications are we on, and then take you into North America, because this is a global company. What's North America doing, and in a supply chain environment, what's that mean to this community, and how are we going to do a kind of an operations-based example. So what is our company? We are a 50-50 joint venture. Our shareholders are Rolls-Royce Corporation, or PLC in England, and Goodrich System is the other partner. They are electronics controls that actually they're in a wide market. They do a lot of different things, but we took the electronics control portion. So you ask yourself, why would they form this joint venture? What's important about it? If you look at the industry, aircraft engines, the top three producers, number one is GE, number two is Rolls-Royce, and number three is Pratt & Whitney. Well, very competitive market, commercial, defense, all the aspects are very, very competitive. When you look at control systems, and that's where our focus is, two of them, GE and Pratt & Whitney, have in-house control for Pratt & Whitney. GE Woodward is with, obviously, GE. Rolls-Royce had a traditional supplier relationship with Goodrich. So they looked at the long term and said, over the last 50 years, the turbine engine technology has gotten to a point where materials and designs have hit their kind of plateau. You can do some more design work, but it's getting much more complicated to drive it into the design without having advanced control systems, meaning much more software, functionality, efficient fuel pumps, those kind of things. So Rolls-Royce looked at that and said, we got to have a competitive partner in this. We can't just do the traditional supplier relationship, or we're going to lose out to these other companies. So they went and partnered with Goodrich and formed this joint venture with the mission, the purpose, become the world's foremost provider of engine intelligence. And that's through engineering solutions and manufacturing quality products at the right cost. So joint venture partners, I'm not going to read through all these points. You can see that. You've heard the names. Large companies, $17 billion on Rolls-Royce's side, another $7 billion on Goodrich's side. Two large companies. They didn't go into this lightly. This was not just an ad hoc experiment. This is a very serious partnership. They're trying to drive a competitive advantage in the market. So our formation. We formed Rolls-Royce, Aero Engine Controls in the UK formed in January of last year. So they're almost on their 2-year mark. North America formed in October. The real takeaway from this chart I want people to understand is that middle ground, the special security agreement. What that really means is it separates our two companies. We are both Aero Engine Controls. We want to say we're one company, but at the same time, we are two different legal entities. And the point of that is that we can work on contracts with the U.S. government that are classified. That's what allows us to be different. That's what will allow North America to exist and do a lot of different things that the UK won't be able to be involved in. In doing that, we have two different boards of directors. UK has a board of directors, and Simon Burr is the president of Aero Engine Controls in the UK. Denny Warner is the president here in North America. He unfortunately wasn't able to be here today. He's actually in the UK meeting with some folks. So, but that is the arrangement we have with the global organization. Locations, we have several locations worldwide, but the main locations are really Birmingham, England. That's where the manufacturing site is, and engineering services. Derby, England, which is a large software group working with Rolls-Royce. That's one of their locations. And then Indianapolis, which Rolls-Royce Corporation, used to be Allison Engines. That's the group that I came out of. We support the Indianapolis-based products. Applications. If you've heard Rolls-Royce's name, they're on almost every market you can imagine the aircraft turbine engine industry. Airliners, everything from the 787, the new Dreamliner, 777s, A340s. Military side, a lot of U.S. defense products, the C-130J, which heavy lifter for the U.S. Air Force, the B-22 Osprey, Global Hawk, advanced UAVs. So corporate and regional. If any of you flew here to Indianapolis on a regional jet, the Embraer 145 as a 83,007 engine made in Indianapolis, Indiana, with an Aero Engine control system on it. So we're in a lot of different markets, a lot of different products, and you know, you go into, so what are the products? This is the list. This is the main set of products we have. You look at the top, electronic engine controls. That's the brain of the engine. Interfaces with the avionics, controls the efficiency of the engines and how things work. Go down to the bottom, you have main fuel pumps and meter units. That's all about how the fuel system works and keeping the engine going. And then the other one that's growing is engine health monitoring. You look at the warfighter, especially in the military, look at the warfighter, even commercial. Commercial has a disruption index. How many times are my engines down unexpectedly and costing the airliners money? Competitive market and airlines, they cannot be down. The warfighter, they look at operational availability. I cannot be down and have my guy on the ground be unsupported. So engine health monitoring is really growing and saying, can we get to the point of prognostic health management? Can we get to the point of predicting when that engine needs to come off and plan things better so we don't have disruptions in operational availability? So there's a lot of areas where Aero Engine Controls is going to be able to make an impact. So now I go back to what does it mean to the United States, North America. Indianapolis was set up, like I said, as a separate entity, and I think the key takeaway from this chart is the top left bubble, new opportunities. We're going to work with the U.S. government, Department of Defense, on the advanced engines. There's a lot of advanced work going on with AFRL and DARPA and those kind of organizations on programs like Advent and HEAT, variable cycle engines. Everything to do with that means you have to have a sophisticated control setup. You can't just do the average. It's going to be a lot of hard engineering work to get to a new solution that's efficient for the next needs of our military. So that's really the purpose of North America. That's why we're here. But it also has other benefits. Rolls-Royce Corporation, dealing with our customer, being on site, being close, allows us to build a better relationship and look at how their needs from a different perspective. It also lets us have a cultural understanding. You know, UK and US, it's a lot better if you can put someone in place and have the same cultural understanding and go talk to somebody in a global market. So that's the main reason why the US subsidiary was created. Where are we going? What are we doing? So what's it mean to this crowd is the way I would look at this. What are we doing today? Engineering solutions for Rolls-Royce. We're taking on UK work out of our AEC UK. But where we're going is, again, Department of Defense. Liberty Works is the advanced engine development organization within Rolls-Royce in Indianapolis. Working with them, working with Goodrich. You know, Goodrich has other needs in other business sectors throughout the United States we're going to be able to work with. And long-term, assembly and test. So this is the global supply chain and manufacturing. We're going to be putting an assembly and test organization in Indianapolis in the next few years. So that's where this organization is going, and a lot of excitement. We're really excited to get into this. Now, if I look at how are we going to get there, one of my keys, and I'm director of programs. Of course, I'll put this in front of the engineering chart. One of the ways to go is everything is managed by a program. You know, program management is critical. Executing on cost, on schedule. I heard you talking about the projects. We delivered on cost and on schedule. That's near and dear to my heart. Everything we do, integrated product teams, everything has to be integrated together to be successful. Everything from business capture to earned value management, keeping the customer in focus is the key for our success in Indianapolis to really create credibility. We may be Rolls-Royce and Goodrich put together, but we're a new company. We have to get our name out and be credible. So now I'll put up the engineering chart. Now I'll talk the engineering side. The other part of credibility and growth is developing and growing your engineering capability. And that kind of goes in two different areas. First area, you've got sustaining work you're doing now. You've got to look at different innovative ways to be better. And the other is developing new credibility, new capabilities. The next, kind of the way we're doing that, and we're taking, maybe this isn't manufacturing, but we're taking some thoughts from manufacturing. Lean approach. We've actually infused the lean approach in our life cycle of software development. So we're doing lean software development. We have Kanban boards for software. You know, we're trying a different approach. We're saying, can we take something from a manufacturing environment, put it somewhere else, and make it more efficient? similar to doing a transactional project in Six Sigma. Where we've gone in this is the folks in Indianapolis were mainly systems integrators and requirements folks. Didn't do coding, testing. So we've already grown the capability in Indianapolis. We're now doing that full life cycle. We do requirements definition all the way through design, code test, integration with the engine. We're doing that now. We've got a major program going on, and I'll have a product at the end of the day. So we take that into our next fields of electronics and hydromechanical systems, pumps, and products can come out of that. And that's really what we're trying to get to. And then factory of the future. So if you get those capabilities in electronic design, next thing we'll be making the product. You're going to prototype it. You're going to build the product. Where are you going to build it? We've looked at the Rolls-Royce approach. They actually built a new facility for the Joint Strike Fighter lift fan. It's a focused factory assembly and test. If you ever get a chance to tour it, it is an absolute state-of-the-art, fabulous facility. We're going to take that same approach, which means our supply chain has to be on top of things. We're going to have a very good supply chain if we're just going to have assembly and test just in time, don't want high inventory. Looking at, are we going to do Kanban? Are we going to do kitting? What's the best approach for our assembly and test facility? Good news is I don't have to do it alone. I've got two huge parents that obviously have a large supply